Welcome to another video on Better Together. The Better Together videos highlight the benefits of pairing database workloads with Amazon Elastic Cache. In a previous video, I talked about general RDBMS workloads that can benefit from being paired with AWS Elastic Cache. In today's video, I'm going to talk about Oracle-specific workloads. Workloads that after being paired with Elastic Cache will have a boost in performance and a reduction in total cost. Thus, the two services together are better. In today's video, I'm going to share with you tools and techniques how to identify Oracle workloads, and I will introduce various architectural migration options depending on where you currently are in your Oracle workloads to add Elastic Cache to your architecture and calculate sample cost savings and boosts in performance. Hello, my name is Stephen Hans. I'm a Senior Solutions Architect and I specialize in in-memory databases. So let's just first understand the economics. Why is this important and how is this thing is going to affect your overall workload cost and performance? In the above graph, in the current graph here, you're going to see that on the x-axis we represent the request per second and the y-axis the cost. So basically, as the number of requests per second increase, so will the cost. Initially at the lower rate, but later on at the higher rate. This has to do with the scaling options Oracle has, such as scaling up, as in vertically, larger and larger instances. So in some cases, this will double your cost, or scaling out, adding multiple read replicas, which again will increase your licensing cost, storage cost, networking cost, and so on. So as you add more and more resources to it, so will the cost increase with it. But what if you could flatten this curve? Now this next curve represents an Oracle workload that had been paired with Elastic Cache. Now you can see that it will flatten that curve. You could achieve much higher requests per second at the lower cost. And there's an intersection there. And that's what I'm going to share with you, tools and techniques to find that intersection, where these two curves intersect, when it makes sense to add Elastic Cache to your workloads, and to which workloads is not, because not every workload qualifies. It doesn't really matter. In all cases, you will see a boost in performance, but in some cases, you will see both a boost in performance and an increase in cost. So before we dive into that, let's just have a quick recap of Amazon Elastic Cache. Quick overview of it. So Amazon Elastic Cache, it's an open source compatible service, meaning that it's compatible with two compute engines actually. It supports both the Memcached and the Redis engines. It's a fully managed service, meaning that you don't have to bother with acquiring hardware, configuring the hardware, installing software, managing that, patching that. Even minor version upgrades are taken care for you automatically, as well as monitoring. As of late last year, 2023, we introduced a serverless version on Amazon Elastic Cache, which is basically completely serverless. You just pay per use. You don't even have to bother with capacity or scaling. All of that is taken care for you. Basically, you just use the service as much as you need and you pay for as much service as your consumption-based service as much as you used. Both services, the older one, the provisioned one, the instance-based, and the new one are highly available with 4 nines availability, supporting multiple availability zones with automatic failover, automatic recovery if needed. Both services can do that with very fast response time for both services. We're talking about millisecond response time and millions of transactions per second. So you could scale both as far as performance and as far as number of transactions. The services are secure. That's very important here at AWS. They both support a number of encryption and safety standards, security standards, including encryption at rest and encryption in transit. And they both scale. In case of the provisioned instance-based, you have to manage your own scaling, i.e. when to scale up, when to scale down. You have to set your own thresholds and manage that. For the serverless one, you don't have to do that at all. It scales for you as needed. You just pay for the consumption. So let's see that how to identify Oracle workloads that can benefit from caching, now that we know what it is. So first of all, only specific workloads are good candidates. First of all, the workload has to execute more reads than writes. So a higher read to write ratio. 70/30, it's ideal. Higher than that, it's even better. So the higher the read to write ratio, the better the workload is for a caching. Next, if your workload has a database with multiple read replicas, so it's kind of like gives it away. You have multiple read replicas because the database is doing a lot more reads and it had to scale out. This is one of those examples of scaling out, adding multiple read replicas. So that's another good indication that this workload is a good candidate to be paired with the caching service. Workloads with repetitive reads. So kind of like explains the theory that if every read, if there are lots of reads, but if every read is a unique one, then it doesn't really matter whether you have a cache or how you size your database, how big it is. That means every one of the reads are going to go down to storage because they are unique. They cannot be cached, so they have to be repetitive reads. And finally, you got to the point in your workload that your overall database cost is just too high. And you're thinking about other options, such as completely rewriting your applications, maybe migrate to a NoSQL database. Well, you may not have to do that. That's a big undertaking. It's probably going to take a lot of time and work on your end and may be very expensive, costly. So in those cases, if your database cost is high, maybe you should consider adding a caching service to it to bring down those costs. And I will show you some examples how is that possible. Various architecture diagrams will show you that. So these are kind of like the workloads that qualify. Now let's just look at some tools and techniques how to identify those workloads. Now that you have an overall idea, you have to drill down a little bit deeper to make sure that you have those repetitive SQLs, that these are really good candidates. The first way that you can do that if you're already in the cloud is to use Amazon CloudWatch. Amazon CloudWatch could help you identify the read and write ratio, how much data is going in, how much data is coming out. So it's an easy way to figure it out. Or you can use Performance Insight. If you enabled Performance Insight, you could turn it on for 7 days and have a good idea, find out the top SQLs, have a graphical way of monitoring what your database is doing and identify workloads that are good candidates. Now, if you're on-prem, then you have to use Oracle native techniques, and I will show you a SQL command that could help you to do that, how to find out top SQL commands and whether you do a lot more reads or a lot more writes. Another option to you available if you're on-prem, it's a tool that you could download that had been updated. It's called DBCSI, or Current State Investigation, and I'll show you a bit more details on that. This is a tool that has been around for some time, but now it's updated to include recommendations for migration, including Elastic Cache, not just a straight lift and shift. And finally, third-party tools. If none of that works, then you can try to use some third-party tools that could help you identify workloads. So let's just have a little detail. First, I talked about CloudWatch. Yes, you can use CloudWatch metrics at the command line to find out the bytes transferred in or the bytes transferred out. So basically, read-write ratio. This will tell you in a quick calculation. You can see the difference between read and write, and you will know that the workload is read or write heavy. You could set a period of time. Obviously, you don't want to set it down to an hour. You want to have a larger period of time, maybe 24 hours, to find out what the database is doing in a 24-hour session. If you do it during a 1-hour session, it's possible that a backup is running or data is being loaded. It's not sufficient. You want to have at least a good 24-hour window. And then you will see it what the workload is doing. What if it's a cyclical workload? So that's why you can't just pick a 1-hour session when a specific workload is running. Here is a graphical version of CloudWatch. If you configured your console, you could use your CloudWatch, and in this case you can see that this database is doing constantly a lot of reading. So there you go, it's a good candidate. It's not just a 5-minute snapshot, it goes on for several hours, and you can see it that is doing a lot of read. So easy way to figure it out. Good candidate. Now another tool that I mentioned, if you're already in the cloud, is Performance Insights. Performance Insight, similar to CloudWatch, gives you the drill-in capabilities to find even the specific SQL commands. In this case, you can see the top SQLs and see how many times they have been executed, i.e. to find those repetitive SQL commands. So these are the options you have if you're already in the cloud. Now, if you're not, if you're on-prem, you have to use the native ways, Oracle native ways, which is always available to you. You can do that even if you're on the cloud already. If you're already in AWS, you could use the native ways, but if not, these are some of the options. So for example, you can use Oracle snapshots, part of the stats pack, and take a couple of snapshots, maybe a couple of hours apart, or take a few snapshots every hour, compare them, and then you will see basically what the database is doing, the read to write ratio, and you can even identify the top SQL commands. Talking about identifying top SQL commands, one way to do that is to select count basically the number of executions from a $SQL table. This is going to give you information of all the cache SQLs, how many times has been executed. Okay, talking about it, here is a sample SQL command. So you could select the number of executions. Buffer gets is the logical reads. Disk reads, obviously the physical reads. So this way you could find out how often the SQL was executed, how many logical reads it has executed. So get more and more details about it. This is a native way to do it. I talked about DBCSI earlier if you're on-prem. So the DBCSI current state investigation had been updated to help you with migration from on-prem to the cloud. And the feature that it has is that in the past it recommended an instance-based migration, but now it recommends, if the workload is such, it actually is going to look at past workloads, AWR reports that are stored in your database. It's going to look at past performance. And if the database is such that is executing a lot more reads and writes, has repetitive reads commands, then it's going to execute it's going to recommend, based on the execution, it's going to recommend two migration options. One, a strict lift and shift, and the second one that is highlighted there, the one that includes adding elastic cache to it, and it will try to do a calculation for you as well, what size of a cache you might need, even trying to calculate some sort of a cost savings for you. So very interesting, very good tool that you could use on-prem. It's not going to make any changes to your database. It's just going to look at past performance, current database configuration, and it's going to give you two recommendations. Talking about migration and recommendations, let's just look at some sample migration diagrams. So let's just look at what if you're in this situation, what are your options to migrate to a different architecture that includes elastic cache, that basically will boost the performance of your workload and reduce costs at the same time. So the simplest thing that you could do, as I said, depending on your cost, if you're just going to look strictly at the cost, and maybe you got to a point that you want to see what are my options because my database cost is trying to get out of hand, let's just look at the very simple calculation. You could do that on your workload. In this case is when you have a database that is running at the Excel instance and everything is good, but your application has scaled. So it's one of those examples when your application is scaling, your database is going to scale with it vertically. And basically the simplest thing that you could do is to bring in a bigger database instance. So from an XL, go to 2XL. A 2XL will give you twice the CPUs, twice the memory, almost twice the throughput. The networking is not necessarily going to double, but yes, you will get more for that, but your cost basis will also double. So in that case, you have the option to add elastic cache to it for a flat fee. This is an example where you add an instance-based example, which is calculated at the flat fee, no matter the consumption. So yes, what's the difference? Well, without the elastic cache, you could scale up. Yes, you could double your performance, but it will cost you about $1,300. But with elastic cache, it will cost you a flat fee of $300. So the difference is about 4x. Now let's just look at the more detailed architecture diagram that includes a production Oracle database that has a primary database and a read replica. So in this case, the database is running on a 4XL instance. And this is because the demand was such to meet read and write demand, so the database was put on an instance size that would satisfy that. So obviously a solution like that would run about $123,000 a year. Now if you were to migrate this to the architecture on the right, where we add elastic cache to it, well, the database is still going to have a primary database and a read replica, but instead of a 4XL, a 2XL instance is sufficient, because all those read requests now can be farmed out to elastic cache, which is going to cost significantly less. So there you go in comparison there. Now the new architecture on the right hand side costs only $77,000, which is about a 37% reduction in total cost. And all what you had to do, add a caching service to it. You're not going to lose any of your high availability. You still have a primary database standby, and the cache itself is highly available. So this is an example of scaling down actually. Maybe previously you scaled up vertically, you could scale down. Let's just look at another example. This example has to do when the database administrator has decided to scale out. So basically, multiple read replicas have been added to the workload. So in this case, just two. We're not talking three, four, just two read replicas have been added. So the client application is already such that separates the reads from the writes. It uses one way to write to the database, to the primary database, and then it reads from the read replica. So that's a very good position to be in, because the application has mostly been updated already to separate the reads from the writes. Now, let's see how we could migrate this potential architecture to one that includes Elastic Cache. Now, this is the new architecture. And in this one, the read replicas, the Oracle read replicas, have been replaced with Elastic Cache. The instance size actually remained the same. The primary database instance is still the same size, so the writes are not going to be affected. The same size, but it actually a standby database was added in a secondary AZ. So now the database became highly available because it utilizes two availability zones. In the past, the primary database, the previous slide, the primary database and the two read replicas were in the single AZ. Now we have a primary database and a standby in a secondary AZ, so the database is highly available, and so is the cache. The reads and writes are still separated. The writes are going to the database, the reads are coming out of the cache. In the event the data is not in the cache, you do a one-time read from the database, and then you update the cache with that. The cache itself, again, is highly available with multiple nodes spread out across multiple availability zones. Now this actually I have modeled in our labs, so let's just see the performance gains and the cost difference that one might anticipate. In our testing, where we used an 80-20, 80% reads and 20% writes on our workload, simulated workload, we have simulated 400 users, and our response was the following: about 18,000 transactions per second, TPS, with an average response time, ART, average response time of 21 milliseconds. That's the combined average response time of the reads and the writes observed on the client side. Okay, and this architecture cost about just over $100,000, $101,000. Now let's just see the new architecture, how does that breaks down. So in the new architecture, we were able to push up the TPS to 24,000. That's a 33% boost in performance. And the average response time went down to 12 milliseconds. Again, the combined read and write response time. That's a 42% reduction. Let's look at the cost. The cost went down by 20%. Now let's imagine that you haven't done this and your demand is to keep increasing the request on the database because your application has scaled. Perhaps using containerized solutions or something similar, you can always increase your application, and you had to add another read replica to your database. So in that case, your cost would be even higher to achieve the similar 24,000 requests per second on your database size. So in that case, your database cost would go probably in the 130,000 range. So your costs are going to be even lower. So in this case, you can keep scaling your application, but not your database cost. Your database cost will remain the same. So let's have a quick recap about the database workloads that can benefit from this. Well, you will have a boost in performance and a much lower application response time, as this last slide has demonstrated. The response time went down by 42%. You could offload all those I/O work from the primary database into a caching service and scale at a much lower cost. Here are some QR codes to read up more on Amazon Elastic Cache. There's a QR code to a blog that will detail you how to set up your own testing if you want to test on your own to see what kind of performance boost and response time you might see and cost savings. There's a blog there that goes into a lot of details. And some learning path to learn more about AWS Elastic Cache. And here are the QR codes about the tools and the products that I mentioned before, such as CloudWatch, Performance Insight, and Database Current State Investigation, or DBCSI, the Oracle specific workloads that helps you to migrate from on-prem to the AWS cloud. This concludes today's video. Here's my contact information or my team if you'd like to learn more.